Here is a sentence you have probably heard. The AI read the whole internet, and that is where its knowledge comes from. It feels true. It is also, in two different ways, wrong. Because the thing that decides what a model knows, what it is good at, what it gets confused by, is not some magic in the math. It is the diet. It is the exact pile of text it was fed, one word at a time, until it learned to predict the next one. Which means the real product, the thing labs fight over and pay for and lose sleep about, is not the model. It is the data. And in 2026, that data has become a quiet drama. We are running low on the good stuff, and we are arguing in courtrooms over what was even fair to feed it in the first place. Today, we look at what the AI actually ate. Let us make this concrete because it is the foundation for everything else. Remember from Season 1 how a model is trained. You show it an ocean of text, you hide the next word, and you nudge billions of numbers until it predicts that word well. Do that across trillions of words, and the patterns of the text soak into the weights. So think about what that really means. The model never memorized facts from a textbook. It absorbed the statistical shape of whatever it was shown. Feed it brilliant, careful writing, and it learns to write carefully. Feed it the noise of the open web, spam, broken pages, the same paragraph copied 10,000 times, and it learns that too. There is an old idea in computing, garbage in, garbage out, and nowhere is it more literal than here. A model is, to a first approximation, a compressed echo of its diet. So the most important engineering decision in the whole pipeline is not the architecture. It is what goes in the bowl. So where does the food come from? At the start, mostly one place. A massive free public archive of the web called Common Crawl, which has been scraping pages for years, billions of them refreshed every month. Open that fire hose and it is overwhelming, petabytes of raw text. But here is the thing nobody tells you. Most of it is junk. Navigation menus, cookie banners, spam, auto-generated gibberish, and the same content duplicated again and again and again. If you trained directly on that raw fire hose, you would get a worse model, not a better one. So the real work, the unglamorous work that quietly decides who has the best model, is filtering. You strip the boilerplate, and crucially, you deduplicate, you find the near-identical copies and keep just one, because a fact repeated 1,000,000 times should not drown out everything said only once. Then you score what is left for quality, and this is the part that surprised people. One open project called FineWeb found that the single biggest jump came from training a small judge to ask, does this page read like it is actually teaching something? Keep the explanatory pages, drop the rest, and the model gets sharply better. FineWeb distilled years of that messy archive down to a clean stream of around 15 trillion words, and a smaller, cleaner dataset beat much larger, dirtier ones. Let that sink in. Less data, better model. The field has a name for this lesson. Curation beats raw scale. Now the twist that is keeping people up at night. If clean human text is the good food, how much of it is there? It turns out you can actually estimate this. Researchers added up the world's high-quality public human writing, books, articles, code, the useful parts of the web, and got a number that sounds huge but is not infinite, somewhere on the order of a few 100 trillion words. And the models are eating it fast. The careful projections suggest that, on current trends, the frontier labs will have effectively used up the supply of fresh, high-quality human text sometime this decade. The field has a name for this: the data wall. Now be careful how you hear that, because it is easy to overdramatize. It does not mean AI has read everything. It does not mean progress stops. People write new text every single day. What it means is narrower and more interesting. The era of just scraping more was always going to end, because the cheap, abundant, easy human text is the part that runs out first, which forces a question. If you cannot just find more good text, where do you get it? Here is the answer the field landed on, and it sounds like cheating at first. If you are running out of human text, make the text yourself. Use a strong model to generate fresh, high-quality training data for the next one. This is called synthetic data, and a few years ago it was a fringe trick. Today it is a standard ingredient in how the best models are built. It shows up in two main ways. First, a strong model rewrites messy web pages into clean, textbook-quality explanations. One effort rewrote roughly 2 trillion words of web text into a cleaner form and recovered most of the good content that plain filtering would have thrown away. Second, a strong teacher model generates millions of worked examples, careful step-by-step reasoning that is hard to find naturally online, and a smaller student learns from them. That second move has a name you will hear a lot: distillation. The big model teaches the small one, so synthetic data is not a desperate last resort. It is a way to manufacture the clean, dense, well-explained text that the open web was always short on. The food supply is no longer just found. Increasingly, it is grown. But this should make you nervous, and good, because there is a famous warning here. What happens if AI keeps training on AI, on and on, a copy of a copy of a copy? In 2024, a study in a major journal showed something unsettling. If each new model is trained only on the previous model's output, and you throw the real human data away, the model degrades, generation after generation. The rare, the unusual, the edges of the distribution, those fade first, and the model drifts toward a bland, narrowing sameness. They called it model collapse, and for a while the headlines screamed that AI was about to eat itself to death. But here is the part the headlines left out, and it is the whole point. A follow-up study showed the collapse only happens if you replace the real data with synthetic. If instead you accumulate, you keep the human data and add the synthetic on top, and then you filter and verify like always, the collapse does not happen. And that accumulate and curate is exactly what real labs do. Nobody throws the good human text away. So no frontier model has visibly collapsed. The lesson is not that synthetic data is poison. The lesson is that you must never stop keeping the real thing, and you must never stop being picky about what you keep. So you have your data, clean human text plus careful synthetic. One question remains. How do you split your budget? You have a fixed amount of computing power. Do you spend it on a bigger model or on feeding a smaller model more words? For years people guessed, and mostly they guessed too big, training huge models on too little text. Then a study from DeepMind, the one everyone now calls chinchilla, found there was an actual sweet spot, a balance between model size and the amount of text, that gets you the most capable model for a given training budget. They called it the compute-optimal point, and it sits at the heart of what are called the scaling laws. The rough rule of thumb that came out of it, give or take, was something like 20 words of training text for every parameter in the model. Hear that number loosely. It is a ballpark, not a law of physics. But watch what happened next, because it is the clever part, and it is very 2026. That compute-optimal sweet spot only minimizes the cost of training the model once. But a model is trained once and then run billions of times by billions of people. So if you can make a smaller model that is cheaper to run, it is worth deliberately overspending on training it, feeding a small model far more text than the sweet spot says, 10, 20, even 100 times past it. The field calls this overtraining. You pay more upfront once to get a small, fast, cheap model that punches far above its size every single time someone uses it. That is why so many of the small models you can run on your own laptop today are so surprisingly good. They were overtrained on purpose. There is one more part of the diet we have to talk about, and it is the messiest because it is not a math problem. It is a fairness problem. All that human text the models ate, the books, the articles, the art, the code, the forum posts, somebody wrote that. And around 2025 and 2026, the world was still fighting about whether it was okay to feed it to a machine without asking. I am going to give you this as a snapshot in time, because by the time you watch this, the details will have moved and some of these cases will be settled. As of this filming, the early rulings were drawing a careful line. One U.S. court suggested that training a model on lawfully obtained books could count as transformative, a kind of fair use, but that downloading pirated copies to build the library in the first place was not okay, and the lab in that case agreed to a settlement reported at well over $1 billion over those pirated books. Major news organizations were suing other labs over their articles, and those suits were still in progress. And at the same time, the same companies were quietly signing licensing deals, actually paying for data from forums, from publishers, from archives. So the verdicts are not final, but the trend underneath the noise is. Data is shifting from something you just take to something you pay for license and have to keep records of, with a clear paper trail of where each piece came from. There is a word for that paper trail: provenance. The free buffet is closing. Where the next models eat from, and who gets paid when they do, is being decided right now. So let us put the whole bowl back together. A model is, more than anything else, its data, a compressed echo of what it was fed. That food started as a filthy fire hose of scraped web text, and the real magic was filtering it down to a clean stream, because curation beats raw scale. But the clean human text is finite, and we can see the data wall coming sometime this decade. So the food is increasingly grown, not just found, synthetic data and distillation from strong models, which stays safe as long as you accumulate and curate and never throw the real thing away. Throw it away, and you risk collapse. Scaling laws tell you how to split your budget, and the modern move is to overtrain small models so they are cheap for everyone to run. And wrapped around all of it is a fight happening right now over who owns the words and who gets paid. So the next time someone says the AI just read the whole internet, you will know the truth is stranger and more human than that. It ate a carefully chosen, hard-fought, and increasingly paid-for meal. And what we choose to feed it next is, quietly, one of the most important decisions in the whole field.